Hello, and welcome back to Quantitative Reasoning Online. We'll be going into the Part 9D preview assignment, which will get us to, I have the page up already. Which gives us this page here. So let's go and let's look at why you're wearing the same old socks. Hopefully they're kept clean and not just being worn over and over again, but we shall find that out, and I'd rather not know the answer. So let's look at this guy. We'll be looking at bivariate data, which means 2 pieces of points for every information. We will create a scatter plot and describe the trends and the correlation present in the data. Create a trend line and read an article and identify statistical information. Exciting things. Trend line, ooh, Excel. Okay. Next class extends the discussion about correlation into the concept of causation. Just remember, correlation does not always imply causation, but sometimes it does. We will be able to create and analyze a scatter plot and create a linear trend line, Excel. Unless your instructor has told you otherwise, you may create the plots by hand or with a spreadsheet or other technology. Tutorial begins here. All right, what do we got here? We have here the spreadsheet of, let's see, looking at the average daily membership of a school, for its high school. So for 11th grade, in the year 2000, had average daily membership of 232. In the year 2006 was 272, and in 2013, 251. 12th grade was again 2,000, 191, and so forth. So the given year and the number, who's on first? I mean, who's the average daily membership of 12th graders. All right, now the next graph is a comparison of the 11th grade admission, average daily membership, compared to the following year's 12th grade. So let's see, so the saying is, in other words, table 3, row 2, we have the year 2000 11th grade enrollment and the year 2001 12th grade enrollment. Just think about it. This year's 11th graders are next year's 12th. This year's 11th graders are next year's 12th graders. So let's see if this jives. Okay, 11th grade, 2000, 232. 12th grade, next year, 2001, 12th grade is 190. 232, 190. All right, so yeah. So all these things count. So go down to here. This would be 2000, 2001, 2002, 2003, 2004, 2005, 2006. This should be 2007, 11th grade, and this should be 2008, 12th grade. So let's see, is 2007 275? Yes, it is. 2008 was 228. 275, 228. So yeah, so these data points are taken off the previous charts tables, just off by a year. Because 11th grade are next year's 12th graders. And it's called pair data because technically it's the same students. So what do they want us to do with this? Let's see. If your last name begins with any letter A through M, you will work with table 1. If you're like, we're going to do both. So let's see. So what variable should be the independent variable placed along the y-axis? All right. the independent variable, horizontal axis, independent variable basically x-axis, and sometimes we want to call this the explanatory. Okay. So we're going to, so the x is, we'll try to explain what's happening in y, the response, which would be the dependent, by the way. Y-axis response. Okay. Yeah. P-O-N-S-E. So what explains what? Does the year explain what the average daily membership is, or does the average daily membership, does that explain what year it is? So what is the variable that we can use to help explain the output? Does year explain average daily membership, or does average daily membership explain year? Okay. And in each case, we'll use the year to determine what the average daily membership is. And same for 2. I mean, they both, the year would be the explanatory for on what the average daily membership is. That 2. All right. How do I move to that? Okay, here we go. Here's the change button. All right, let's clear the button. Let's clear the ink. All right. Create a scatter plot of your data. Be sure to label your graph well. Bring the graph to class, which the following is the best description of the behavior of the average daily membership. All right. Personally, I think let's go to Excel now because we're going to want to graph this. Okay, so let's do a graph. Oh, by the way, I kind of skipped this part. Wrong button. Somewhere in here would have been the ability to get that spreadsheet. Just click on this guy, you'll get this. So let's do a scatter plot of 11th grade. All right, so scatter plot, so this would be, the year would be our explanatory, our x-axis. Average daily membership would be our y, our response. And to make a quick scatter plot, in Excel, highlight. We will insert a graph. What kind? Oh, here's recommended. Let's go to our charts. What I'm going to want to do is a scatter plot, an XY. Now let's do it right up here too. And I just want the data dots. All right. So here is the average daily emission for 11th graders. Let's add some details. What is this bottom axis? Let's give some title to the axis. So let's add some So this is the year. Always have trouble getting these highlighted. Yes, so 11th grade ADM. So there's our 11th grade one. done in a few seconds. For 12th graders, same thing, highlight the data, insert a scatter plot. Let's add a title. Again, takes a little bit of work. Year, twelfth grade ADM. ADM. Come on. For 12th graders. All right. Let's go back to the paper. Okay. So let's see. We have taken the question: is there a strong positive correlation, a strong negative, or neither positive nor negative? Now, what we're trying to do is, the intent is, can the year explain the average daily membership? And I'm just looking at it, it looks like it's pretty much, at best, a very weak positive. Actually, it was kind of like pretty flat. And it says it's like positive, but generally flat around 220 or so. So what are the options again? Strong positive, strong negative correlation. That is not strong. So I'm going to say neither positive nor negative. Same with 2. Okay. Oh, play with the scale. I'll show you how to do that in a second. No clear trends. Student enrollment goes up and down. If you're working table 1, it stays close to 250. Table 2 close to 225. Yeah, so let's play with the scale here. How do we do that? Well, because I want to kind of like blow up the effect. So highlight it. There we go. Uh-oh. So just what you want to look at, just kind of click it a few times. Aha, axis, units, major. I want a minimum of 150. The lowest number, and that sounds good. I'm going to keep it that way. There we go. There we go. Okay. You may want to say there's a bit of an upward trend here, but be careful when you kind of like really blow these up. You kind of like sometimes lose the lose some of the effect or over amplify an effect. But that's how you change the scale. Just click on it, bring up this window, and there you go. There you go. And it looks like it goes up and down. What's next? Yeah, positive and negative varies. There were important trends present in each data set. You may be able to find additional information applying to 2 data sets to pair data. Order pairs that contain a number of blah, blah, blah. Okay, based on what we discussed earlier with the, remember, this is the 2011th graders, and these are the 2001 12th graders, because 11th graders become 12th graders. Table 3 shows a pair of memberships. All right. Choose a description that best describes the data. The 11th grade ADM is continuously increasing. Now it goes up and then goes up and down. Up, up, down, up, 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 12th grade is increasing continuously. 12th grade is always less than 11th grade. Let's see. Less. Yes, less. Okay, yep. Definitely 12. 11th is decreasing continuously. Definitely not decreasing. All right. In a way, it could be 11. It could be the first one too, except they use this word continuously, which means it never goes down. So to be increasing, then that should not have happened. And that should not have happened. Again, increasing continuously. Okay, from here to here it goes down. And here is going down again. So it can't be the first two. So it has to be this guy because, yeah, they are. The 12th grade is always a little less than the 11th graders. All right. Create a scatter plot of the data and bring the class of, okay, this stuff. Which group makes the most sense as the independent variable, 11th grade ADM or 12th grade ADM? All right, again, the independent, which one is being explained? Which one's the response? So what I want to have the 12th grade data to explain what's happening in the 11th grade, or would it make more sense to have the 11th grade data be the explanatory for what's happening in the 12th grade? What do you think? 50, 90, you know. 50% chance means 90% wrong. Or 50% chance means wrong 9 times out of 10. I'm going to go with, it makes more sense that the 11th grade explain the 12th grade people. All right. So let's make the data now. So let's make a scatter plot of this data. Insert, chart, scatter plot. Oh my, a lot of clustering here. Got a little bit of work to do here. Again, data or titles. 11th grade ADM. Grade ADM. Let's expand this out between 2 to 300. Oh, wrong one. Highlight it. Here we go. Let's have minimum value to be 200. And the maximum value to be 300, that's fine. And let's I'm sure which one I got here. There we go. And let's bring this up to 100. Okay. How does this compare to the graph here? Pretty good. Pretty good. Follow juniors. Now it's the same. Okay. Again, look at the data. It looks like, well, let's answer questions. All right. 11th grade comes first, and the 12th grades follow. The 12th is the ADM is dependent. Okay, cool. Now, looking at the graph, choose the best description. Is there any kind of correlation possibly inferred from the 11th grade to the 9th grade? Okay. Now, mind you, it's not necessarily in order. Okay. Here we go. So look at this guy here. Oh, shoot, highlighted. Okay, this is the point when the 11th grade is 285, the 12th grade class will be 228. When the 12th grade is 240, 11th grade is 242, the 12th grade is 203. Okay. So just because this is first, doesn't necessarily mean this is going to be the first data point. The first data point here is 231, 187. That's here. The second point is 232, 190. That's the first one. The third one is 242, 200. Where's that guy at? That's the second one. 245, 203. That's the fifth one. So they're not necessarily in the same order as being done here. So the size of the 11th grade class can be used to predict the size of the 12th grade class, is what this is saying. And there's a very strong positive correlation to it. Positive and strong correlation means, yes, I can make a prediction. Positive just means as the explanatory increases, the response increases. Think of the positive or negative correlation as being the slope. A positive slope, a negative slope. Let me say here. Yeah, positive correlation. And even though 12th grade is always less than the 11th grade, class that have higher enrollment in 11th tend to have higher enrollment in 12th and so forth. So how well is it correlated? Now let's throw a trend line in. Well, there's the equation, there's a line. And what equation would it be? Well, there's your prediction equation right there. And there's your R squared. We'll get into that later. All right, I'm talking too much. Time to move on. Okay, review the prompt and response. Estimate the slope of the trend line either by using the data in row 2 and 12 or by finding the trend line of your spreadsheet graph. Hey, we just did that. Your spreadsheet. Looks like it's let's see if this works. I really don't know. Nope, can't copy it. So let's see. Trend line is 0.8108x 1975. So, the slope. So the slope of the graph is 0.8108. What did I say? 8108. All right. They picked 2 points, they picked two data points out of the table and figured it out. Spreadsheet, 0.81. More accurate. All right, read the article. All right. Let's pull up the article. Copy. And what are we looking for? According to the article, there are how many cases of sudden infant death syndromes each year in the United States? Oh no, let's go find out. Gotta find it in here someplace. Ah, here we go. Story begins in the 1920s when researchers first started considering possible cause for SIDS, which responds for 2,500 infant deaths per year in the U.S. alone. I actually lost my cousin lost a child to this. Only number I see. So let's go with 2,500. And 2010. Okay, yeah, well, I got, yeah, that's where we looked. Yeah, 2,500. Okay, we got that one correct. We read it correctly. Review the prompt and enter response. What did the doctor hypothesize as the swollen gland that might be causing SIDS, sudden infant death syndrome? Let's see what we got here. Read. Researchers found that many of the SIDS infants seem to have a large thymus gland. I'm not quite sure what thymus is. I'm not pre-med. Pressure on the trachea, someone in the throat, I guess, causing suffocation. Interesting. Article states the doctor began treating children with swollen organs with radiation. This treatment helped reduce the incidence of SIDS. Eesh. Radiation nowadays. Putting pressure on the trachea. Fan-like. Parents irradiate their children's thymus gland, limit thymus swelling and growth. You consider an irresponsible parent if your child did not undergo the procedure, so thousands did it. It seemed as though science had provided them a miraculous breakthrough. But everyone was completely wrong. What are we trying to answer again? Oh. Saying it's completely wrong, I'm going to say no, but let's finish reading. Let's see. To do. Parents' swollen thymus gland first were in fact our first glimpse of normal-sized thymus gland. In other words, the radiation treatment was useless. All the doctors have been wrong. Real human cause next to thymus, thyroid next to thymus was also exposed, and a lot of them died as an adult with thyroid cancer. Wow. No. Okay, can you read the table? I think so. Can you create a scatter plot? I do recommend when you go back and do the video is play with the Excel features. I mean, it's very easy to do scatter plots. If you have bivariate data, the first will always be the X. And so basically, this will be the X data, and this will be the Y data. All you need to do is highlight, insert what you want, a scatter plot, and then it's a matter of making it pretty, adding your titles, adjusting your axis size, adding a trend line, using more options, throwing in some equations and stuff. So don't be afraid to play with this guy. In Excel, I'm very confident I can get a trend line. And reading an article takes patience. And trying to find that one little nugget of information in 50,000 paragraphs. All right, so we read bivariate data, we created scatter plots, we described the trend and correlation present in data, we created a trend line, and we read articles. So that means you guys are smoking hot to go into the next part. We are now done with the tutorial, and I will see you shortly doing the questions on quantitative reasoning online, part 9D preview. How do I get out of here? Okay, so I shall see you shortly.